Welcome to Lesson 2, Part A. We are going to talk about the first component of the statistical assessment year. Before, though, we have to refine a bit the notion of fitted model that we presented in Lesson 1. In Lesson 1, we have acknowledged that the trade construct is characterized by an exit rule which provides a positive skewness. Then trade returns bias to the upwards, towards profits. Afterwards, we defined a fitted model as something built on top of the trade construct to the purpose of maximizing the percentage of winning trades within the probability space defined by the relevant predictors. That comes handy for didactic purposes, but the real-life fitted models are a bit more complicated. By the way, it wouldn't make sense to maximize the winning trade percentage, because trade returns have a big variance. Thus, there would be no certainty about the profitability of a system optimized in that way. Such a system may wind up taking much more winning trades than losing trades, but discarding the big profit trades and keeping, on the other hand, big loss trades. That may undermine the positive skewness delivered at the lower level and compromise the profitability of the trading system as a whole. Let us refine then the logic of the model fitting. The fitted model doesn't care about the percentage of winning trades. It looks for spots within the probability space where the expected value is bigger. We have a caveat here. This optimization entails a preprocessing of our trade sample in order to avoid the so-called influential observation issue. This preprocessing step replaces the returns of the extremely big profit trades with the 95th percentile of the profit and loss distribution. Accordingly, as regards the losing trades, it replaces the returns of the extremely big loss trades with the 5th percentile of the profit and loss distribution. If we didn't do that, we may wind up forging a system which is trained to pick up just the single biggest profit trade ever, and a big trade of such kind may not occur again in a 50-year time. Such a system would be utterly useless. An expected value-based fitting delivers both benefits. It preserves the positive skewness provided by the trade construct. It assures at the same time an expected value bigger than 0. Great! Here it comes the first statistical test. The purpose here is to see whether the expected value is significantly bigger than 0, which means to assess whether the profitability of the trading system is statistically significant. In statistical terms, a system like this, with this profit and loss distribution, is not significant because the lower confidence limit of its expected value is negative. This other system instead is significant because the lower confidence limit of its expected value is positive. Here we introduce some notation. Y hat equals 1 indicates that we deal with a selected trade, a trade selected by the fitted model. Quite the opposite, y hat equals 0 indicates a discarded trade, something which has no impact in terms of performance. Here we aim at assessing the significance of the system performance, then of just the selected trades. Hence we write expected value with a subscript that reads y hat equals 1. We can also use a more compact notation. Expected value with 1 in brackets. Finally, we come to a real-life example. We refer here to the short strategy on gold. The expected value confidence limit is the light blue band plotted at the bottom of this chart. It clearly stands above 0, then within the profitable trades area. Great! That means that the system profitability is statistically significant. For who is new to statistics, let me clarify what confidence level means. A 95% confidence level means that there is just a 5% probability that our assessment is faulty. The t-test that we have discussed so far considers the full-featured trading system. That means both the trade construct and the fitted model built on top of it. In the next part of this lesson, in the next video, we are going to focus on another kind of t-test, which focuses on the trade construct and on the predictive model separately. The purpose of this refined t-test is to figure out whether the predictive model delivers an upgrade to the trade construct. Well, thanks for watching, and see you at lesson 2, part B.